Right. Hello, everyone. Can everyone hear me, first of all? Yeah? Hi. Nice to see everyone here. Who here has not been to Breaking Convention before? Oh, wow. OK, there's a lot of new faces. Hi, everyone. Nice to meet you. Nice to have you around. So my name is Balaet. Spelled like that. I'm a computational neuroscientist at Imperial College here in London. And for the past 5 years or so, I began to be very fascinated with how psychedelics could be used as memory modulators. And you may wonder how this entire thing started. So about 5 years ago, when I was an undergraduate at the University of Birmingham, I was doing quite a lot of in vivo work in models of addiction and PTSD, trying to use derivatives of ketamine, such as like MK801, to disrupt the reconsolidation of memories. I'm going to talk about what this means a bit later on. And while the experiments worked, and indeed we managed to suppress such memories of addiction or traumatic memories, for example, the drugs that we were using did not really survive clinical trials, and they were deemed to be neurotoxic and not suitable for humans. And that's around the same time, maybe 2014, when psychedelics literally started having a boom in terms of research. And what was being said about them is that they are non-toxic and they're much more suitable for human intake. And that's how I decided that they might be a very interesting substance to look at in terms of how we can use them as memory modulators. And this is what I'm going to talk about today. But first, let's talk a bit about Sally. Sally is a smoker, and she has a proper problem with smoking. Whenever she sees someone smoking, she really wants to get a cigarette herself. So just let's do a little imaginative exercise and think that Sally has access to psychedelics therapy and goes for an LSD session, for example, with a therapist, works through her addictive memories of smoking, and then afterwards she no longer wants to smoke. So what I'm going to explore in this talk today is how exactly we might go about doing this and what's going to happen. But first, let's talk a bit about consciousness. So what we are looking at here is a phylogenetic tree that illustrates the evolution of brains in all animals and other creatures that have brains, such as humans. So the human brain is somewhere over here, for example. And why is this important? It's important because I want to make a statement that consciousness might be a product of evolution. And if we go along the lines of the theory of evolution, throughout the years, the nervous system has evolved into this contained organ named the brain that we have. And that is how we ended up being these conscious beings that we are walking nowadays. And there's a theory that was started by Gerald Edelman, which is called neural Darwinism, that explains this in a bit more depth. So in the brain, we have different structures. We have different types of cells, different neurons that are specialized. So there is this aspect of differentiation between different cells that are involved in generating our conscious experience. And all these cells are connected by synapses. And this is very important because we have a structure that has a certain functionality. We have this functionality that's intercommunicating with one another. And then we also have something called re-entry, which means that the brain, unlike a machine, for example, has the ability of constantly updating the experiences and the feelings that the human is having based on current experience. So along the same lines, we may say that this is what led to the development of consciousness. So there are 4 properties of consciousness. For the purpose of this talk, and I've been accused of solipsism yesterday, we're going to talk about embodied consciousness, which means that all the conscious processes that we're going to discuss are generated by the brain, and they're only possible because of this organ that we have. So consciousness is embodied. It is contained within the body. It is also personal. There's no two humans that have the same conscious experience as one another. And it's also continuous, which means that we're not going from one conscious state to another naturally, unless we're suffering with epilepsy. Hopefully not. And I would hope no one who's healthy goes from one conscious state to another, meaning that suddenly you're fine and then you feel drunk the next second. That would not be very nice. And it's also the consciousness is also dependent on attention. So, for example, we may say that we have one cake in one hand and one book in the other. If we choose to focus on the cake, we might feel very hungry suddenly, and that affects our conscious experience. But if we focus on the book, then we might think of other stuff, like, I don't know, the exams that we have coming up, or preparing for talks. There has been a lot of work done on consciousness by someone called Gerald Edelman. He was doing a lot of work illustrating how memory is related to consciousness, and arrived at the idea that consciousness could be regarded as the remembered present. Sorry for this screen. This is the imperial computer being funny. Right. And what do I mean by consciousness is the remembered present? I mean that in any given moment, the sum of the things that we are remembering are actually accounting for our conscious experience. So you may think that you know when your flight is, what you had for breakfast, what you're going to do throughout the day, and that is what constitutes largely what makes your conscious experience. And this is why memory is very important. But I might just do the slide once again, because this is annoying. So, yay. Ish. Let's just ignore that bit. Right, so let me just define memory very quickly. So one of the widely accepted definitions of memory is that it represents the sensory information gathered from outside that is then processed by the brain and then laid down in a specific memory. And this memory has specific processes. So these processes are encoding, consolidation, encoding, which means literally laying down the information, consolidation, which are some processes that come up after we lay down the information that ensure that the memory is going to be stored and then retrieved. And then the fun bit, which is the reconsolidation and the second retrieval, which is where if we are acting in a certain way, we may be able to influence the outcome of what we're remembering. I think we're not going to get rid of that at any point soon, so that's fine. And what I'm going to do is to take each of those memory processes in turn and talk a bit about what they are and how psychedelic drugs influence that. And just to quickly say what psychedelic drugs are, just in case people are not necessarily familiar with this and you came here to find out. They are mind-altering substances. Psychedelic basically means mind-revealing. This is where the term originates from. And they are known for triggering profound alterations of our conscious experience. They can lead to visual hallucinations, such as seeing geometrical patterns or experiencing synesthesia, feeling a lack of boundaries between the self and the world around, or feeling that everything is connected. There is a wide range of effects that psychedelics can have on the human brain. And we know from the work that Robin and colleagues have done at Imperial that they also have a profound effect on the brain because they increase the brain activity and the communication between networks while also decreasing the activity in the default mode network, which is responsible for the everyday living states, such as daydreaming, for example. And while this is what happens in the brain, inside the neuron, this is a neuronal membrane. This is the 5-HT2A receptors. These drugs are producing their effects by binding on the 5-HT2A receptors. We have the example of LSD there, binding on the serotonergic reception and triggering this insane cascade of protein connections inside the neuron. And this is what produces the effects. I find this particularly fascinating because it's literally a lot of tiny, tiny things interacting together and giving rise to a very, very profound experience in the actual consciousness of people. Which is absolutely crazy. And although we're starting to learn more about this mechanism and uncover them, it's truly a magical thing to think that this might actually lay behind the experience. Next. Please go. Please go. Yay. I think we... Yay. Right. So as I said, I'm just going to go through each of the memory processes in turn and talk a bit about what they are and how psychedelics especially impact that. And we are here. And sorry about the entire slideshow thingy, but yes, that's meant to happen. Right. So we're talking about encoding, and encoding basically means laying down the information in the brain. It has been previously hypothesized that the way that the brain encodes information is by creating engrams. However, this is widely disproved in the scientific community at the moment, because it literally means that you have a physical structure in your brain that is responsible for keeping your memories together. So the reason why this is not actually accurate anymore, although people used to believe this ages ago, is because experiments in rats, for example, have shown that once you eliminate a tiny bit of the brain, then certain memories do not go away. Therefore, memories are not necessarily bound to one specific part of the brain, but are part of a wider dynamic system of remembering. So external stimuli, such as visual or acoustic stimuli, tactile or semantic, are processed by the brain. The integration is happening via the thalamus, and then those might be stored or not, depending on whether we make a conscious decision to do so. For example, the prefrontal cortex has a role in this. You can be your own agent and see whether you want to remember something or not. For example, if you want to study for an exam, you may want to remember that. But if you're just passing through a city that you're never going to be in afterwards, you may not want to remember that. And one other thing that I need to mention here is the fact that laying down memories is entirely dependent on the hippocampus. There has been some really nice work at Cambridge University showing that when you are trying to memorize something, the activity in the hippocampus goes up, and then straight when you decide to stop memorizing that thing, the activity goes down. And also, this is very dependent on your emotional connection to said memory, and this is why the amygdala is very important here. And it has very close connections with the hippocampus, especially because they are very structurally close together. So when we think about psychedelics now, we may think that they may increase encoding of memories, especially because they increase the emotional salience of things that are around us. And one good example to illustrate that is, let's just say you're looking at, I don't know, a coffee cup, but you are on LSD, and you find that meaning of life is attached to this coffee cup. You are probably going to encode that memory way better than if you just pass by my coffee cup right now. So psychedelics arguably increase memory encoding. Then after the memories have been encoded, they have to undergo a process of consolidation, and this is basically what decides whether the said memory is going to stay into the brain or not. So there's two types of consolidation. One is called synaptic consolidation. And if we look here, for example, so these are neurons, and this is what is called a synaptic cleft. So when you excite a neuron, then the neuron is going to release glutamate, and glutamate is going to displace these magnesium ions that are blocking the NMDA receptors. Then afterwards, calcium can come in, and this is, in simple terms, what the process of laying down a memory and consolidating it is. The more this process happens, the more it leads to long-term potentiation, which means that the memory is more likely to survive over time. And if the process is not happening and the neurons do not fire together, then you have long-term depression, which means that that memory is not going to survive. Well, since we've just seen some pictures of the scans on the LSD study that illustrate that we have increased activity in the brain, this also means that we have increased glutamate release by the neurons. Therefore, we might infer that psychedelics increase memory consolidation, and that is one of the reasons why the experiences are very, very profoundly ingrained in someone's memory. Now, talking a bit about storage, storage could be regarded as a massive library within the brain. It is really unknown how large the long-term memory storage is in a human. But what would be interesting to do with psychedelics here is to study whether people who are consistently taking psychedelics in their youth, for example, have a better recall of their autobiographical memories later in the years. This has not been done before. This is something that has not been investigated, but it is an interesting research avenue. And in terms of short-term memory, my research shows that people cannot really hold more than 5 things in memory at once. However, there are some people who can go up to 8 distinct elements. By element, I mean different words or mathematical formulas, for example. And then we have retrieval. There's 2 theories centered around how retrieval happens, and that the first one is the 2-stage memory retrieval, which means that when you're trying to recall something, you're going to pick certain elements from your brain, and then, not consciously, this happens in the subconscious, and then you're going to compare them and see which one fits best. So for example, if you're thinking of a pencil, then your brain is automatically going to compare, am I thinking of a pencil or am I thinking of a pen, and then move on with that. However, there's also another theory called the encoding specificity theory, which says that retrieving memory is based on situations. One way to illustrate this would be you're studying for an exam while chewing gum. And then when you chew gum again, you are going to remember that information much easier. Now, in terms of psychedelics, the hypothesis is that they do increase the memory retrieval and they increase the repertoire of memories available, which is something that I'm going to illustrate in a moment. Right. And finally, we're getting towards reconsolidation and applications of this framework. So let's remember Sally from earlier. So as I said, Sally is a smoker. And one day, Sally decides to go to the shop to buy a sandwich and doesn't take her cigarettes with her. So this was not me. This was not me either. So in front of the shop, Sally sees someone smoking a cigarette. I get many questions of how is addiction related to memories necessarily. When you have this visual cue, for example, of seeing someone smoking, that might evoke the memory in Sally that she feels great pleasure from smoking and therefore she really wants to engage with this behavior. So Sally goes to the shop and is not satisfied. However, let's now come back to the original idea that Sally might undergo some LSD psychotherapy and get to work with a therapist on this. So the way that this would happen is by during a session, reactivate the said memory, which means think about it, try to imagine that you are in the actual moment. And what this does, it triggers novel protein synthesis and all the processes that are relating to encoding that I was talking about earlier. And this makes the memory liable to disruption. It's like you're opening a window where you can change what you've previously learned. That's why when we are remembering things from the past, for example, and then there's a family member that says, no, you didn't do this when you were 5, you're imagining all that, then you may change your memory and update it because your memory became liable to disruption for the very reason that you've remembered it. And then you can create novel associations in that moment, and the memory is going to be updated. So later on, when you are going to recall the same thing, you're going to have it in a different fashion. So the way that Sally might go about this is to talk about it in a session and associate the smoking sensation with something different from pleasure. So next time when she's walking around to the shop and sees someone smoking, she's going to have a completely different recall of what smoking means for her and generally. So one way that I thought might be easier to visualize this is by using these boxes here. So let's just imagine we have a human that only has 5 memories stored in their brain. Like the 5 memories are the only thing that exists for them. And these are represented by each of the blocks here. And one of the memories is the memory that bothers them. So we may go along with the same example of smoking and say that this memory is the bothering one. In the sober state, the person has access to some of these memories, in our current case, 2 of them. One of them being the one that's bothering them for obvious reasons, and the other one being just another memory that ensures that they can go about their daily life, like where they put their car keys, for example. But once the person is undergoing the psychedelic therapy session, for example, the repertoire of memories that is available to them increases. So that is why at this stage, Sally might be able to recall 4 memories rather than just 2. And the reason why these are shaped like clouds is because in the psychedelic state, there is this high suggestibility aspect to it, which means that the memories might not be exactly as you are, as you've encoded them. So you may have changes of facts and this confabulation that goes on the top of the actual memory. Also, the reason why these clouds are bigger is because the detail referring to each of the memories increases at that stage. However, after Sally might undergo the psychotherapy with psychedelics, she might make novel associations with what smoking means, and then at the end, when she comes back to being sober, the memory is clean, it's nice, and she doesn't feel the need to smoke anymore. So, right, I've been talking about this for quite a lot of time, and when I mean a lot of time, I don't necessarily mean now, I mean for the past 4 or 5 years. I realized recently that no one has ever raised concerns about this type of ideas. We're literally talking about memory editing here. And that's why I think that I want to be the one raising the concerns here. So it's quite interesting to think about the fact that we may be able to change how someone experiences life by altering what they remember about themselves, who they are, their daily practices and their work. However, what is really important to mention here is that the intention matters, and this is definitely not something that has to be done at home. Definitely do not try to edit your memories in your room at home using psychedelics. This is something that should definitely be explored more first of all, in a more controlled environment, and then in more naturalistic settings, and certain guidelines are to be developed before we can move on to actually saying that this is safe. So I just wanted to make a mention for this. So there is a lot of more research that needs to be done into how psychedelics influence different memory processes, and we also need to investigate the neural mechanisms alongside how the subjective experience manifests. And it's very important to define guidelines for what memory editing therapy would be, and carry out risk assessments, because this is definitely a complicated topic, and we shouldn't leave any room for things going wrong. So what I would like you to take home from this talk is that there is evidence to suggest that psychedelics can be used as memory modulators, and applications for this include depression, addiction, and post-traumatic stress disorder, as well as any other conditions that may have a strong memory component that is affecting people's everyday life. And one other mention, which I need to make, I'm a huge proponent of naturalistic settings for studying psychedelics. This project, for example, this is a field study in Denmark, and one of the experiments that we've carried out there is looking exactly at how psychedelics increase this repertoire of memories available. So this bit. So there is data coming out on that. And it's probably going to happen in the next half a year or so. But yeah, what I want to say is that usually with memory experiments, there's this concern of ecological validity. For example, it's quite difficult to say that, okay, we're going to ask someone to come to the lab and then give them a list of words or a story to memorize, and then they're going to comply with the task, because that is something that feels very unnatural to them. And I just wanted to basically make a statement about the fact that studying psychedelics in the real world, where the experiences actually happen, might be very, very insightful for understanding processes such as memory. So this is part of the future directions and where this set of work is going. And it's part of a wider study, which I'm hoping to finalize on memory editing. So yeah, I just want to thank my friends and family for everything, my Borderland crew and my lab at Imperial for everything. And thank you guys for listening. And if you have questions, shout. Thanks.